Okay. So, yeah, hello again. This is my third time at Magad UK. It's great to be back. I'm Henry Stamerjohann. I'm from Apfelwerk. I live in Hamburg, Germany. And we are probably known for an open source tool that is named Central. And you may have heard of that from previous presentations that I've run here at Magad UK, or you read about it in Slack or somewhere else. However, Central will not be covered that much today, more briefly, because it's about building your OS baseline requirements. But before I start, I want to share a story that recently a friend told me, or better, a colleague, because he discovered a potential breach at a new project he was assigned to. And so there was an inventory system that was running behind a reverse proxy. TLS was in place. Only a limited group of people could log into the system. But so altogether, a very common setup. But he discovered that the web server that was also sharing the directory where the database file was sitting in. So this is pretty bad, because by downloading the file, you would have the data, the inventory data of all the Macs in the company. And this is a potential asset to have for a targeted attack. So such mistakes could be prevented by applying well-defined hardening procedures. And yeah, so this is something I'll probably cover a little bit in my talk. This is the UK edition. So building your macOS baseline requirements again. So today we are using a lot of different machines, desktops, laptops, servers, watches even. And so we use containers, and many of them are not staying in the network, in the corporate network anymore. And so we are tackled with an ongoing pressure, an effort to secure the systems or the IT systems of any kind. And so also bad actors are trying to get onto this. So there's a continuous vulnerability assessment happening by the good people who try to find the thing to fix it, but also by the bad people who want to just get in. So there's phishing campaigns and all that happening. So the systems we use are really put through their paces. And yeah, so we are responsible for protecting them and the users and the data that is on the systems. So, and it's especially important because of the new GDPR that is kicking in Europe, but it has an effect worldwide. So, because this will change the picture of how you have to act, the timely manner you have to act, and also the consequences that you face in terms of the data breach. So, you really have to consider that if you haven't done that already. So, just imagine that a situation, a colleague or a boss of you will ask you to follow the ventures of what the Windows team just has proceeded. So you're asked to build a comparable Windows security baseline for the Macs. Then you have to explain, no, GPOs don't work for the Macs because, yeah, it's Apple. And you're also tackled with all the new things that happen with MDM. So you need to have that MDM project rolling. And then the InfoSec people will challenge you, why do we have to trust the Apple IP range? Well, yeah, because it's Apple. So instead of this as a response, you accept the challenge. So you start working to create and refine your security baseline. And you have to define the standards for all your Mac workstations for installing software, hardening them, and bring them into production. So, but you should also include the servers and all the services that are your clients, your Mac clients are depending on. So, which is Monkey, Jamf, FileWave, and the like. A lot of the why and how was covered yesterday by a great session from Sam Keeley. So if you have been there, yeah, so just it's complimentary, hopefully. And so if you haven't been there, just check it out. It was pretty good and very on spot. So building a security baseline is an ongoing challenge. So there's a lot of things that you have to consider These are just a few examples of the components your security baseline is built of. So inventory control, yeah, we almost do that. So we can manage updating our software. So we can run OS in place upgrades with the management tools we know. But there's certain stuff that we may need to think of, or that we have to refine for the future. So yeah. And it's also important that we train our users, because they have to be aware of why things are not working, and you don't have to block them in their productivity. So a baseline is essentially just a set of basic objectives, mostly turned to security, and they should be met by any device that is in scope, and all the systems you're using in your environment should be covered under a baseline. So if you only run a partial integration, this could be enabling a potential threat. So you likely will have to build a scenario that is covering more the high level as well as the technical in-depth, and you have to probably create some documentation for the high level. So we are using Jamf, or we are using Monkey for achieving this, and then in detail you have to say, okay, we have to set our screensaver to 15 minutes, and that's how we do it. So this is practically what's written in the baseline. And so, yeah, the idea is to enforce the standards for compliance and security, because this is just another way of saying this is another aspect of quality you want to achieve in your organization. So it's about stability, resilience, and confidence in your IT systems. So, and the data is the most important asset you have in your organization. So the baseline should contain the actions that are needed to protect the data and the user. But you need to balance out the security aspects and the user's productivity. This is very important. So in total, you have to find your personal holistic modus operandi for your organization. Because in the end, this is your security posture you're building on. Okay, so these are the common things you already know. Patching software, just disable the services that you don't need. Prevent client-to-client communication where it's not needed. And so just you want to take all those measures to make defined settings to prevent that information collection of any kind of getting in, staying in, and acting is possible. There will be exceptions, and almost if you've done something, you will find some gaps, so you have to recurringly look after that and keep improving your security stance. Because it's important that you make sure that the baseline is set up in a reasonable way. Otherwise, you just risk that there's another failed IT initiative going on, and as said, derogations will be expected, but make sure that you note them clearly and challenge them again. Because, yeah, just read it up here. As said, it's good to have a structure of your documentation. This would be just one example. It's almost, I don't know, 18 years old from the SANS Institute. So in that terms, nothing has changed, but in reality, the technology has evolved a lot. So in detail, a documentation could look like this. This is just from CERN in Switzerland, how they have laid it out. I hope it's okay that I use this as a reference. So, but when I was mentioning the Windows people, what are they doing? So they have a tool which is known as the Microsoft Security Compliance Toolkit, and it's a set of applications and some guides and reasoning behind it, and they also have like a very detailed checklist for every setting to apply. But we're Apple folks, so where do we look this up? Apple is not providing that to us, but there's some good resources. You may already know the CIS Center for Internet Security. which have a very good benchmark document. So every item has a description, a rationale, the audit you have to take, and also the remediation steps. And this is something you can follow along and applying that for your management system. And some people have done that. So for, let's say, for Jamf, there's open sourced a set of extension attributes already available, covering a lot of the stuff that is in CIS documentation in the benchmark. There's also very good crowd community documentation available under this link. In the end, I will show just a short QR code where all the links are available, so don't. And within here, so they are covering the basics, but also very in-depth details. And there's, even if you this is on GitHub, if you just star the repo and you just follow the ongoing discussion, you really can see how the different perspective of people happens before something is approved to be listed up here. So as it's about to setting something on the devices, we have to have some techniques to do that. So these are the items that we usually use, configuration profiles that we can distribute over MDM or manually or via Monkey, whatever. We use scripts, command line tools, software, AV, that stuff. And of course, there's some conditions we have to aggregate to make some decisions on behalf of that. So if the screensaver is not set as we expected, so we have to enforce that it's looking like it should be. And there's also the last resort, the MDM commands of remote wipe and lock, and these could be also part of your baseline. So the facilities we are using is the Jamf, Monkey, and all of them are just running in a scheduled interval to just check, is there anything I have to apply? And usually this is where you have the rules set, a script kicks in, makes the setting, and then it's applied to the systems. However, as you're not targeting one but many systems, you want to have some feedback, which is the reporting or a dashboard and logging facilities. And it's also good to have some change detection in mind, because otherwise you're staying pretty blindfolded. If, let's say, inventory happens a day, then of course after that day, when the inventory received the information, the setting is not as expected, you can reapply the setting, but a day is 24 hours, could be long. But running a recon in Jamf every 5 minutes, probably not a good idea if you have a couple of hundred max and they are running an inventory, your database will grow a lot. So, however, there's also tools to do a very thorough check on configuration towards hardening. And so this tool is also a great starting point to just apply to your current systems and see what it's reporting on, and just refining your baseline with all those guides and tooling around. Let's go to a new topic. I found this gem in the Slack security channel a while ago. And of course, not all the apps we have to distribute are probably code-signed, sandbox, or come from vendors with a very good security stance. And it's good to know this ahead before we deploy it, before an incident happens. So, because if we deploy just the software as is from auto package and we just promote it, it's a little bit like playing bingo. And so it's exciting to play a little bit bingo on executions, and this is something you could do or you should do, just inspect what's inside. Here's 4 applications, and I'll just present about how many binaries and how many scripts are in. So because of the timing, I have to just not go and ask you, just show it to you. 8 binaries are embedded in Firefox and 0 scripts. Google Chrome, it's 12 binaries and 6 shell scripts. So Atom has 30 binaries embedded inside and comes with around 144 scripts, Bash, Python, Node. All of this is executable, and how do you know if this turned bad with whatever process, update, something you installed on top? And next, Xcode. Is this number correct, Joel? No. No. It's that many binaries inside and that many scripts of many kinds. So, and why is this important? Because even Apple has sometimes to fix this, because Git was vulnerable and this was part of Xcode. And they can't just rush out and replace Git inside of Xcode, because it's the core of Xcode, and they can't just replace only the Git binary. They have to run a full cycle of release, and so yeah, they addressed it with a update of Xcode at that time. So the repercussions you will see is that you have to acknowledge there's the risk of malicious binaries on the systems, and especially for developers, there could be things happening where the code is tampered with, or they built in a backdoor mechanism without even knowing that. There was a very great talk at the CIS Computer Congress last year that just covered that, and so I really recommend to go out and check this out. Because the flaws in the development tool chain could be, of course, the risk of code execution from the package managers, and so some code could be hidden in the build scripts that is turning evil, and even there's more evil stuff in there. So this really covered quite well in the talk from the CIS Computer Club. Let's go to the good, the bad, and the ugly. So we have a tool like Nessus. This is a commercial tool, but it can do a very thorough check on your clients as well as your server infrastructure on the versions that are installed in there. And it can give you feedback if, let's say, a CVE for Git became available. And so tools like that can help a lot. However, you can also run a tool like inspec, which comes from Chef, and which allows you to program a desired state check in quite a simple syntax. So really check out inspec. You describe what you expect, and you can check this out on a local system or run against a remote system, and then you get the results and see flagged when it fails or when it succeeds. This is an example. You just describe, okay, I expect that a shell call OpenSSL version gives me that version number, and then so I also check the exit status when calling up the binary, that it's not crashing. And I do the same for OpenSSL version, which was installed by Homebrew. And with this check, if I'm running that, so I can see, okay, my baseline is not matched on my development chain, so I should go and fix this. And this script could be part of your developers using that, because you as a team can, or they as a team can define the baseline, and they can check that out for themselves. Because if everything's fine, it looks like that, and yeah, well, this is a great tool, Inspect by Chef. Homebrew, some people love it, some think it's pretty bad, because I personally think this tool can turn ugly very, very well anytime, because it's installed by curl to bash. It's executing a script. It asks for admin privileges to proceed. And so you have to give a lot of trust to what's going on. And are you really knowing what's going on when you run a brew update? Of course, there's a community. They have the effort of making it well, so some security measures are existing in Homebrew, but as especially in a diverse team, when they spread out, it's a very asynchronous fashion of running brew updates. So from the admin perspective, you're pretty much blindfolded here. A little hint, OS Query can help you to inspect the versions across the systems. So yeah, so one reason to check out OS Query. But Homebrew is problematic in terms of a regular change management process because it will not work in the way how Homebrew is designed. So this whole Homebrew topic would be a good talk for another time. And yeah, I'll see if I make that next time. So as said, application and lifecycle management is important, and a lot of organizations have to follow those standards more and more. And what could you do? So of course, inspecting the content of an installer is the first step, just seeing what's inside, what's in the structure. But you could do more than just that. You could install it on a test system and run some extra tooling for recursive fingerprinting on all the binaries. Then you can compare what the results in between versions, and so you can make some discoveries in that way. Here we have Oracle Java, the Internet plugin, the Java Internet plugin, and this is the version 9.0.101. And so if I just change that to the newer version, you will see, okay, the hashes for all the binaries that are part of that Java are the same, but there's a shell script in there which is which was not changed. But why does an Internet plugin need a shell script? So I haven't known this before inspecting that. So seriously, do you want to have this going on? If you make discoveries of any kind, discuss them responsibly. So this is the Slack channel for security, and there was made the discovery first on the EFI check. So discuss this in a smaller group, get some feedback, because to do it responsibly is a good idea, and probably not do the Twitters. So the security baseline should also apply to your management infrastructure. So there's the recommendation you hear often, and I also agree with that: run configuration management, create multiple layers of defense, limit the access to APIs and to accounts, and use logging as much as possible. Simple example, this is Jamf. They have a change log. You can just look something up. But what happens if the Jamf server is down? Don't see the log, right? And if you don't have SSH access, can't see the log, right? So it really helps if you ship off the log file to a central place, because then you're much faster in drilling in to the same events. This is Kibana, where the log file was just shipped over, and you have different mechanisms of finding specific events much quicker, and you make some inspections that usually you wouldn't do in just when you are in the management interface of Jamf or other systems. There's a very good guide of securing your systems, because MySQL, Postgres, Apache, Nginx, SSH, and these are the things that you want to harden, especially for Linux and Windows servers. And this is just like a open source repository that is using Puppet, Chef, or Ansible to apply what is defined here as good measures. Okay, change detection. I mentioned OS Query. OS Query becomes a hot topic and is very popular these days. How many of you are using OS Query already? Any hands? Oh, just a few. Go check out OS Query. There's a new website. There's also a QueryCon happening in May or June in San Francisco. And OS Query really helps you to run checks against the settings you've applied, and run the checks in a recurring fashion, and it can alert you. There's great tools for managing OS Query. So the majority is open source. There's StreamAlert, Doorman, Fleet by Collide, Zentral, the project we do. And so just to give a short example, okay, here are the projects. And just to give you a short example of how a OS Query recurring check could work, I made up something here. This is a query that will look out for a specific plist file, and it can drill into the plist file and check for just a special subkey, or one of the key values. So as long as MDM is installed on that system, this should give no return. So if OS query is running in a, let's say, every 5 minutes, it should not return anything because everything is fine. However, if MDM is lifted from that computer, it will trigger a result, and then you can act on behalf of that. Oh my God, the profile is missing. Another good tool for binary control is Google Santa. So I really love this tool. The project is, again, on GitHub, open source. They have a very good updated documentation right now. And I showed last year how we do some stuff with Santa in Central by blocking binaries. But today I just picked some different example of just running Santa locally for that kind of inspections I showed earlier. So the Santa CTL, it's just one binary. It has learned a lot of more features over the last few months. So the recursive scanning is very, very helpful to just acquire all the fingerprints, because you have to just drill in to the subdirectories and find every executable, and just Santa can do that. So check out the syntax. Here I have a short example of just drilling into the OpenSSL in a recursive fashion. And here you see, if I'll just press start, how quickly it will run through. And of course, for every file it finds, it creates a fingerprint. And if you save the output as a JSON file, which is possible with Santa, then you can just diff the earlier file, you apply an update, you run Santa again, and then you just diff two JSON files, and then you precisely know where things have changed and yeah, where things have been similar. One of the last things to tackle today is the topic of event streams. So the idea of event streams is just that there's some instrumentation happening on the systems, which are your endpoints, usually performed by an agent, or a process is kicked off, or a script is running. And this will aggregate the information and ship that over to a central place. The central place could also provide some config updates for those agents, and so they could receive new rules or new queries that they should apply to the endpoints. Then the next step would be what you receive as events. You want to apply filtering, because that could help to make out the specific events you're interested in. And if you have something that you want to alert on, you can just program the event stream system that you may use to trigger an action and let you know of in different channels what result was just received. So, and for the post-investigation, it's very good to persist the data somewhere. And that could be achieved by using more modern databases that allow you the historic inspection of just all the events you aggregated from a lot of endpoints. So one project that is doing that is Central. This is the GitHub page. And yeah, so one of the last things I want to highlight today is that there's a very good white paper from Google, how they do their fleet management. And just by reading through, you can learn a lot on that. So rebuilding your security baseline, I hope I could inspire you with a few things. And you should evaluate your current baseline continuously, because it's all about data protection and regulation, and protecting is for a greater good. So that's almost my talk for today. Thank you, and yeah, probably Q&A. Any questions? The link? No questions? Okay, yeah. Okay, just. Oh.
Hello. My question is, security team does Nessus scans.
Yeah.
But I have a problem to verify the issue, test the issue, resolve the issue. Is there a website that can help with that, or information sources? Because it's great having a security team throw out these things, but Nessus scan doesn't necessarily document it well, document the fix well, and things like that. Do you understand what I mean?
So I think that what Nessus is doing, they are checking known CVEs against the systems, and they alert your security team. They open a ticket, and then you have to have the research of what's going on here. And probably if you run in your deploying a tool process on change management, if you run inspections as shown, for example, with the fingerprinting, and you have a database of every software you deploy, where you have the versioning of all the insights, then automatically you learn much more of what you deploy. Of course, it's some effort, but it could be done with automation. And in the end, so Nessus will not provide you a guide how to address a vulnerability in Apache, which is part of macOS. So sometimes it can happen that you address the issue. You may ensure that you lock down the ports, and that you may want to ensure that the firewall is open, that there's even the PF firewall you could use of, and just drill on certain scenarios you see returning to you, and have some security measures that you could kick in just in case. That would be one recommendation.
I mean, the confusing thing is with Nessus scan, it will say Apache version. This is on your machine, and it's got vulnerability, and this, but that one superseded that one. So it throws up lots of things that are a bit of red herrings, if you understand what I mean.
But then it's a bit more of that the security team that pushes you that information is not like filtering that out. They just throw all the information to you, and you have to, as said, do the research. There's not much you can do unless sitting down together and just refining your baseline, and also how you take the actions in a proper manner internally could be organized or improved.
Okay. Sorry. Thank you.
Over there.
Heard it. Thank you very much. That was a great talk. And I have a follow-up question on, you showed the example of drilling down into a software you install on a machine with Java, if I remember correctly. Yeah. And that is a very work-intense task to really see what a software vendor is doing. And once you figured out what they do, and you're happy with the quality or not, what can you, could you elaborate on both, how you can make this task semi-automated, so you can do it so it scales a little better, and also if you find something you see there can be a potential vulnerability, how you would go about addressing that issue?
So of course you could use something like Center and have just a wrapper script that calls up Center. Just Center is doing the hard work for you. That would be one option. Or you can just write. It's just getting a recursive scan with Python, easy. With Swift, should be easy too. And just running a fingerprint creation. This is something you can automate. We've done that for some customers. Of course, this is internal tooling. There's still the idea of implementing this into this whole auto package workflow. My recommendation would be, if you find one way of automating that, just to have a proper way of, you acquire the package, you install it on a test system, you run the thorough scan, you have the output, then you just put it into a CMDB or whatever kind of database that you can even look up later on, because in day-to-day tasks, you are not prepared of, oh, this binary or this program is just updated. It just happens to be on your place. You just take care of pre-checking before you put it out for a deployment. And the good thing here is if there's any thing that you post-deployment realize, okay, this is bad and this is contained inside, let's say, Atom, then you already have the fingerprint. You don't have to start research then. You just drill into your records, you get the fingerprint, and just be aware, Santa can block binaries, single binaries, just by the fingerprint, and you already have it. So it would be just a 2-minute step to just block that specific binary that is part of Atom and have a custom message, hey, dear user, this application generally works, but this binary could not be started for whatever reasons. So this is the security measures we've put in place for some customers. And it's not fully automated, but semi-automated. And there's a good reasoning for having some steps manually. Because if it's a fully automated chain, you get swamped with JSON documents, but nobody inspects that, and you auto-promote. It's probably a bit better from a security stance than just auto-promote with anything in between. But yeah, do a good proper release and change management.
Thank you very much.
I also have, are there more questions? I have just one more thing to show. So this is an interesting thing that we are running at some customers. It's OpenBSM is part of macOS. And so here you see an example that somebody tries to SSH into the system on the 007, on the James Bond's admin Mac. And of course, he tries to log in with a password. This fails, and yeah, we know this. This can happen by a bad actor, but how do you know? So OpenBSM could ship that in some technical steps to a central place. In this case, we acquire that information with Central. So we see the same event here, and then we can also use our tooling with Kibana, and there you can have like a dashboard showing you those incidents. And as the OpenBSM creates a lot of data, this would not scale over thousands of clients. But if you have, let's say, special build systems, CI systems, where you want to know, okay, it's not that common. Probably 1 or 2 people will log in with SSH, but it's an automated process. There's a Mac Pro sitting somewhere, and you know, it's the exceptional Mac that you need to build your iOS applications in your organization. This you will see that very, very often. And hardening that system also on this level to acquire all the OpenBSM information really can help. And with Central, we are able to ship all that we have here, that you can see as an admin, also further to the big CM systems. And this is something that is really kicking in for the organizations who have a very, very high security stance. And they have their, oh, we have some Macs, what should we do? And these are the installations that we are doing with Central, yeah, here and then, just to make this kind of inspection possible. Just one more example. Okay, there's no more questions. I think, yeah, thank you for attending.